Hello dear students, welcome to ECE Academy Benefactor. In this class we will be saying Magnitude Comparator. The topic is from Combinational Logic Circuit. The subject name is Digital Electronics. Okay. Before in this class we will be saying the design of a 2-bit comparator using gates. Before start of design of 2-bit comparator, let us define what is a comparator. A comparator is a special combinational circuit designed primarily to compare the relative magnitude of two binary numbers. It is used, a comparator is a combinational logic circuit used to compare the magnitude of two binary numbers. This is a block diagram of an n-bit comparator where two numbers a and b are taken as inputs, and this a and b are n-bit inputs. After comparison, the outputs are either a is greater than b, a equal to b, or a less than b. For an n-bit comparator, inputs are a and b, n bits, and output are these three possible outcomes: a greater than b, a equal to b, a less than b. Okay. So, now let us see how to design a 2-bit comparator using gates. Design a 2-bit comparator using gates. Start the solution. Let us first write the truth table of 2-bit comparator. So, what we are doing? We are comparing two numbers a and b. A is having 2 bits, let it be A1 and A0, okay, and B number is having 2 bits, B1 and B0. So, we are a 2-bit comparator will compare two binary numbers A and B, each comprising of 2 bits. So, in the truth table we are having inputs 2-bit, two numbers A and B. A is 2-bit A1, A0, B is B1, B0. So, total 4 inputs are there: A1, A0, B1, B0. The output for this is either A greater than 0, A equal to 0, A less than 0. So, we have written for 4 inputs there are 16 possible combinations starting from 0, 0, 0, 0 till 1, 1, 1. Total 16 combinations. You know how to write them. 0 to 15 you know how to write the binary numbers. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0 and 4 ones. So, we have written the binary combinations from 0, 0 to 4 ones, that is total 16 combinations 0 to 15. Now, for writing this output column we have to compare the two numbers. These two comprise A and these two comprise the B. So, if you compare, what is A? A is 0, 0, B is 0, 0. So, A is 0, B is 0. Compare these two numbers, in which condition it will be correct? A equal to B. So, we have made A equal to B as 1 and other two outputs as 0. Now, let us take the next condition. A is 0, 0 and B is 0, 1. A is 0, 0, A is 0, 0 and B is 0, 1. So, what is A stands for? 0 and B is equal to 1. So, if you compare 0 and 1, B is greater. So, in this condition we have made B greater and other two conditions are 0. Let us check the third condition. It is 0, 0, A is 0, 0 and B is 1, 0. That means it is 0, and this is 2. So, what is greater? B is greater. So, B is made as 1. Now, next one, A is 0 0, B is 1 1. So, B is greater. So, A less than B is made as 1 and other two conditions are 0. Now, let us see this condition, A is 0 1 and B is 0 0. That is A is 1 and B is 0. Which is greater? A is greater. So, A greater than B is made as 1 and A equal to B, A less than B are 0. Similarly, we can check all the conditions like this and written the, let us see the last two conditions. A is 1 1 and B is 1 0. A is 1 1 means it is 3, B is 1 0 means 2, 3 2. If you compare 3 and 2, 3 is greater. So, that means A is greater than B. So, A is made as 1 and other two conditions are 0. If you see here, A is 1 1, A is 1 1 means 3, B is 1 1. So, it is also 3, 3 3, both are equal. So, the middle one is made as 1 and these two are made as 0. So, in this way we have to complete the truth table for 2-bit. That means we are comparing two numbers A and B. Each number is comprising of 2 bits, A1, A0, other number is comprising of B1, B0. Okay. Now, for each output column, we need to draw the K map. So, how many bit for K map we have to draw? We have to draw a 4-bit K map. So, we need to draw 3 4-bit K maps for A greater than equal to 0, A equal to 0, A less than B, A greater than B, A equal to B, A less than B. So, looking at this A greater than B, looking at this column, we need to fill the K map. The K map, this is a 4-bit K map drawn for the column A greater than B. So, how to draw the K map? A1, A0, B1, B0. Outer structure A1, A0, B1, B0. It is 0, 0, 0, 1, 1, 1, 0, 1, 1. The numbering here is 0, 0, 0, 1, 1, 0, 1, 1. So, looking at this, we have filled the number of ones. Okay, we have filled the number of ones. Where is 1 here in this A greater than 0? It is here. 1, 2, 3, 4, 5, 6. So, total 6 ones are there, which we have filled it here. I hope you know how to fill this one. Hai? See here, for this condition 0, 1, 0, 0, it means at 4. 4 means where it will be? 4 means 1, 0, 0, 1, 0, 0, this is 4. So, like this you have filled the ones in this. So, for A greater than B, we have filled ones in this K map and done the grouping. So, we are having one quad, 2 second is a pair and here is one overlapping pair. So, we are having 3 terms here. So, for this quad, what will be the term coming here for this quad? We have to look here. What is common? 1 is common. What is 1? A1. In these two columns, what is common? B1. So, what will get here? A1 and in these two B1. This is 0 is common. 0 is common means B1 bar. So, we are getting the term A1 B1 bar. Now, look at this term, second term. This column is common. In these two, what is common? A0. 1 is common, that is A0. Here 0 0, that is B1 bar, B0 bar. So, what will be the term for this second one? A0, B1 bar, B0 bar. Now, for this pair, this is common. 1 1 is common. 1 1 means A1 A0. 2 columns. In these 2 columns what is common? B0 is common. What is 0? B0 bar. So what it will come? A1 A0 B0 bar. So this is the K-map simplification for A greater than B. Now we have to draw the K-map for A equal to B. This is the second K-map for A equal to B. So looking at this column A equal to B, we have filled ones. So we are having 4 ones here. 1, 2, 3 and the fourth one. So with these 4 are filled in this K-map. In this manner we are getting it. So let us write the outer structure. A1 A0 B1 B0. 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1, and we have written this is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. So we know how to number each cell in the K-map. So at 0 we are having 1 and 5, 15 and 12. So and we have filled ones in this. Looking at this column, as there is no grouping, they are single. We can write for this first one, what is the term to be this? This is 0 0 0 0. So the term for this is A1 bar A0 bar, B1 bar B0 bar. That's written here. What is written? A1 bar A0 bar, B1 bar B0 bar. Now for the second one, what is that? 0 1. 0 1 means A1 bar A0. Here B1 bar B0, B1 bar B0. For this term it is A1 B1, A1 A0, B1 B1, B1 B0. So the term here is A1 A0, B1 B0. For this one it is A1 A0 bar, B1 B0 bar, A1 A0 bar, B1 B0 bar. We are getting this 4 terms. Now let us simplify it to less number of terms. So taking A1 bar B1 bar common. So taking A1 bar B1 bar common, so we are getting A0 B0 B0 plus A0 bar B0 bar. In these two terms, if you take A1 bar B1 bar common, what is left here? A0 B0 plus A0 B0 bar, plus in these two terms take A1 B1 term common. So taking A1 B1 term common, you are getting A0 B0 plus A0 bar B0 bar. After writing, we can write A1 B1 plus A1 bar B1 bar dot A0 B0 plus A0 bar dot B0. So this is the expression for XNOR gate. So for this, what is the XNOR expression? A1 XNOR B1. For this one, A0 XNOR B0. So for A equal to B, after solving the K-map, we are getting this expression. Okay. So we have simplified the two K-maps for A greater than B, A equal to B. Now let us simplify the K-map for A less than B. So for solving A less than B, we have filled the number of ones, written the outer structure A1, A0, B1, B0. 0 0 0 1 1 0 1 1, 0 0 0 1 1 0 1 1. In this way we have written the outer structure, and we know each cell number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So when we know the cell numbers and looking at the truth table, we need to fill these ones, and we have filled these ones. Now we are having one quad. For this quad, in these two rows, what is column? In these two rows, what is common? 0 is common. What is 0 indicating? A1 bar. In these two columns, what is common? 1 is common. What is 1? B1. So we can write the term A1 bar B1. Now coming to this second term. For this second pair, the term common is 0 0, and in these two columns what is common? 1. So 0 0 1. 0 0 means A1 bar A0 bar B0. A1 bar A0 bar B0. Okay, now for this third pair, in these two rows what is common? 0 is common. 0 means A0 bar. In this column 1 1 is common, so it will be written as B1 B0. So what is written? A0 bar B1 B0. So in this way we got the output expressions for these three conditions: A greater than B, A equal to B and A less than B. Now let us draw the logic diagram based on these three conditions. So for drawing the logic diagram, we need lines, input lines A1, A0, B1, B0. From A1 we have taken and connected to NOT gate to get A1 bar. From A0 connected to NOT gate to get A0 bar. Likewise B1 bar, B0 bar. So we are having total input lines 8 here: A1, A1 bar, A0, A0 bar, B1, B1 bar, B0, B0 bar. Okay, now look at the expression for A greater than B. For A greater than B, we need A0. This is the expression, no? For A greater than B, the expression is A0 B1 bar B0 bar plus A1 B1 bar plus A1 A0 B0 bar. Okay, this is the expression. So A0 is here. A0. So we need three AND gates, 1, 2 and 3. First AND gate A0 B1 bar B0 bar. It's going to first AND gate and we are getting this term. Second term is A1 B1 bar. A1, this is B1 bar. We have to circle them or darken it to tell that this input of the AND gate is connected to B1 bar. If you don't darken, it means it's not clear. This input is connected to which input line out of these three. So we have to darken it or we have to circle it to tell that this input is coming from B1 bar. Now looking at this third term, that is A1 A0 and B0 bar. These three terms are coming to get connected to an OR gate to get A greater than B. Okay. Now going for the second output, A equal to B. For A equal to B, the expression is A0 XNOR B0. A1 XNOR B1. So here it's connected to A0, B0. A0, B0 connected to XNOR gate to get this term. What is the output here? A0 XNOR B0. Here this one, A1 and B1 given to XNOR gate to get the expression A1 XNOR B1. These two are added, these two are ANDed, dot is there, so it's given to an AND gate to get A equal to B. Now let us see the third condition, A less than B. For A less than B, the condition expression after K-map simplification is A1 A0 B0, A1 bar A0 bar plus A0 bar B1 B0 plus A1 bar B1. So what it will be? A1 bar A0 bar this is connected to A1 bar A0 bar and B0 and is connected to B0. Next term is A0 bar A0 bar B1 B1 and B0, and next term is A1 bar A1 bar B1. So we are having three AND gates given to an OR gate to get the output expression of A less than B. This is how we draw the logic diagram for a 2-bit comparator. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.